Hey guys, it's Mrs. Giesbrecht. We didn't quite finish up 2.11 today, so I wanted to provide a quick recording on application of logarithms and what that might look like for your test later this week. So there's quite a few different applications for logarithms. It really ties in nicely to science, to chemistry. So there's pH uses, which you're going to see a certain kind of equation over here. Exponential growth, decibels. Decibels are in music, right? Like how loud or soft something is. The Richter scale for earthquakes, and then half-life, which again comes back into biology and chemistry. So what we're going to do today, we're going to practice one kind of question using pH uses. This will be the only type of problem that you will see on your Unit 2 test. So it says the pH level of a blueberry is 3.1. What is the hydrogen ion concentration, which is also called H+, for the blueberry? So going back to the last slide, the equation will not be given to you on the test, so you need to make sure that you have this in your notes. It's your pH equals the negative log of your hydrogen ion concentration. So in this example, they're telling us that the pH level is 3.1. So that means I can replace the pH with 3.1. So what we need to ask ourselves is, how am I going to solve for H+? Because that's really what it's asking, right? What is the hydrogen ion concentration? So this is the portion of the problem that I need to get by itself. So first things first, right now we see that it's a negative log, so I'm going to get rid of that negative sign by dividing by a -1. So now what we see is I have my traditional log problem here. Let's ask ourselves, do we see logs on only one side of the equation, or do I see logs on both sides of the equation? And the answer is you only see a log on one side of the equation. When we have log on one side of the equation, I need to take it from log format and rewrite it in exponential format. So in order to do that, we need to remind ourselves, what is the base? It doesn't show you the base right now, which means when it doesn't show you the base, there's really a 10 there. So writing it into exponential notation, I would get 10 raised to the negative 3.1 equals my H+. So that's how we're going to solve. Let me grab my pointer tool for a second. So we did my 10 raised to my negative 3.1 equals my H+. So that is just switching between logarithmic notation and exponential notation. So at this point, it is okay to use a calculator to work out what 10 to the negative 3.1 is. And when I do that, my calculator gives me an answer like this. So 7.943. Then it says e to the -4. So I just want to make sure we remember what an e to the -4 means. That's really scientific notation where it's meaning times 10 to the -4. So what number is that really? Well, I need to go -4 times to the left with my decimal. So 1, 2, 3, 4. So that's really the same as 0.0007943. So on a test, your final answer would show up like this, 0.000, and it's going to round it to an 8. So look over there one more time. When we type it into a calculator, you're going to get this answer, most likely. Most calculators put it into scientific notation. What does e to the -4 mean? It really means times 10 to the -4, which we know that from quite a few years back, I think. You guys learned scientific notation. We have to move it 4 times to the left. 1, 2, 3, 4. So 0.000, then that will round to an 8. So this would be the answer that you would see on a quiz or a test. So have this equation in your notes, pH balance. Get rid of the negative, step 1. Step 2, write it in exponential notation and solve. And you guys should be fine on this section for your test. Thanks, guys. Have a great day.